Hello, Professor. Hello, Professor. Salvatore Periscandola. This is my presentation for Capstone. Um, the Rich Purnell maneuver. It's an FPGA development kit, programming at the lowest levels and just connecting peripherals to each other to create a small clock and alarm program. The objectives were to create the alarm clock, but also, and more importantly, to understand FPGA development and the way that embedded systems work. And all the various tools that come with them, Quartus Prime, using PuTTY, using FileZilla, having a headless OS, things like that. That was the main goal of this, and to learn digital circuits and use them, essentially programmatically. It's pretty impressive software, pretty impressive technology, and I had a lot of fun doing it, but that was the main point of it. So this is the user interface design. These are the only peripherals I actually used, or components on the board that I used, which was the LCD display, the 10x switches, the 4x key buttons, and the 7-segment display. The 7-segment display is obviously where the clock went. The switches is how the time was switched for time zones and also programmed into the alarm. The buttons helped with the programming of the alarm, and the LCD display just had some instructions on it. The code base was kind of based off of a module design or module type design, since C doesn't have object-oriented programming. UMLs didn't really make a lot of sense, but having different function-rich modules was a perfect design. Obviously, I used the onboard components to achieve my goal, and I designed a couple digital circuits. I have one of them in the back of the presentation that uses the switches to control the 7-segment, and it is FPGA. It's a 7, or it's the BCD decoder. But unfortunately, I wasn't able to get it into the clock, and that's where we come with project limitations and known issues. Is the FPGA digital circuit? It doesn't actually work for the clock, so that's something I'm working on and have intentions to build towards into the future, but as it stands, that's the one feature I didn't actually get integrated. This is my Loom Link. I'll be playing the video if there's time. This is the completion to date, so I'm at 92%. I dropped this in here. It's also in the README document that's in the main turn-in. And then let me go find that video, and hopefully it's not too long. It's 3 minutes and I only have 5 left on this, so what I'll do is I'll just fast forward some of it. But you can see that we're switching time zones here, and then back here we start programming the alarm. So we can get to a 12:05 here, and then we'll set the alarm. And there it goes, reorient the switches, and we're back to it in about 30 seconds. The alarm will go off, so we'll skip forward, and that's the alarm going off right there. We'll find the key that turns it off. I always forget it's the third key. I always think it's the first one for some reason, although I'm the one who programmed it. And that's it, and then the FPGA is back here. So we can see that the 7-segment has switched over. It's all blank except for the 1, and we can control that. That's an actual digital circuit. But like I said, it wasn't integrated into the project itself. But thank you very much for everything this semester, all the opportunities you afforded me, and just everything you've taught me. I don't think I'd be the same or as strong of a programmer had I not taken you as an instructor. So thank you very much for everything, and I look forward to working with you in the future and just sharing content and generally having fun. Well, thank you. Hello, this is my capstone demonstration of my D10 standard Intel development kit, codenamed the Rich Purnell maneuver. This is just a clock, and it has an alarm function, and it uses FPGA technology. So I'll explain that as I go. Right now, you can see that we can change time zones. So it's 2 o'clock, 3 o'clock to 1 or 12 o'clock where we are, and then you can program an alarm. So we'll start there. We want it for the 5 minutes. This is the button that started the program or the alarm setting. This will change us to the hours, and we can go ahead and find 12. And then once we have 12 on the board, we can press the secondary key and it will actually program the alarm. And we just reset the switches, and in 30 seconds the alarm will go off. This project for me was just an exploration into technology I had never used before, using some programming languages I had never used and concepts I had never used. The main programming language is C, and there's VHDL and Verilog for the FPGA side of it. I'll give the FPGA demonstration after the alarm goes off, which should happen in about 5 seconds. And there we go. And then we can press this button to get it back to the third button back to the actual clock itself. And we can set a new alarm if we really wanted to. So the FPGA, I'll start the circuit right now. You can see that the board changed over, and you can see that there's a 0, and we can make that 0 a 1, a 2, a 3, a 4, 5, 6, 7, 8, 9. So we can do 1 through 9, and that's actually on the FPGA side of the board, which is a digital circuit, which turned our software into hardware, which was kind of the point of the whole project. Unfortunately, one of the limitations is the clock isn't ran on FPGA, although that is something that I'm continuing to develop. I have a couple workarounds. Well, I have a couple ideas. It doesn't seem like I can communicate with the GPIO pin the way I thought I could, but I'm trying a couple more things, such as just kind of assigning a pointer to it, and getting the pin assignments correct and all that. And then another is designing an expansion port digital circuit to actually create a pointer. I'm gonna get the camera a little closer so you can see that there's actually a message on the LCD display. So that's actually there, which is pretty fun and easy to program. But yeah, this is the Deck 10 development kit. Thank you.